This is 3-1, all about elimination, so keep in mind we're still working with systems of linear equations. We talked through graphing and substitution in the last lesson, and so elimination is another method that we can solve linear systems. Okay, so we're going to be able to solve systems of linear equations using elimination. Here's a 3-step process for you. The basic concept is that we're going to multiply one or both equations by a number, and then we're going to add the equations and we're going to eliminate one variable. That's the big idea here. We're going to eliminate one variable and then solve, and then we will substitute. So we're actually going to use substitution in elimination, and here's what I mean by that. Okay, so the big thing with this, we have to stay organized. The way that I recommend doing that is by kind of labeling each equation. So let's say that 5x plus 3y equals negative 19. In this system, we're going to label that as equation A, and then 8x plus 3y equals negative 25. Let's say that that's equation B. And so notice how I have x and y in both of my equations, and my x's and my y's are lined up. In order to figure out what number x is equal to, or what number y is equal to, or to figure out if this system has infinitely many or no solution, I need to somehow get rid of one of these variables so that I can solve for x or y. So the way that we did that with substitution was by getting one of the variables by itself. So say like I could get y by itself here by subtracting 5x and then dividing by 3, and then I would plug in whatever expression y was equal to. I would plug that in for the y down here. But with elimination, this is really nice for when substitution is not as easy. Okay, so what elimination will do is pretend like we're gonna add or subtract these two expressions. Okay, so I have 3y here and 3y here. Because those are the same, it's going to be really easy to cancel those out, and I can cancel those out if I take 3y minus 3y. So what I want to do, I want to take my entire equation A and subtract equation B from it. So I'm going to take equation A minus equation B. Okay, so to do that, I'll subtract term by term. 5x minus 8x will give me negative 3x. 3y minus 3y will give me 0y. Negative 19 minus negative 25 will give me 6. And now I have a one-step equation. Negative 3x equals 6. That means that x equals negative 2. And now I can back substitute. So I can take x equals negative 2 and plug it into either of these equations. I'll plug it into the top one. 5 times negative 2 plus 3y equals negative 19. What is my y going to be? If I multiply this out and then add 10 to both sides, I get that 3y is equal to negative 9, meaning y is equal to negative 3. So my solution to the system would be negative 2 comma negative 3. Okay. Pause the video, give this one a try. Alright, so if you don't feel comfortable yet trying this on your own, that's okay, or if you've gotten stuck, it's okay. Let's label this A and B. Equation A, equation B. Notice that we have negative 3y and positive 3y. Those are going to cancel really nicely. All we're going to have to do is add them. Equation A plus equation B. And what that's going to do, 4x plus 2x would give me 6x. Negative 3y plus 3y would give me 0y. Negative 22 plus 16 would give me negative 6, meaning that x equals negative 1. Negative 1. Now I can back substitute. So I can take 4 times negative 1. If I'm plugging into this top equation, 4 times negative 1 minus 3y equals negative 22. Negative 3y equals negative 18, meaning that y equals 6. Okay, so if there's ever a point when you're solving this and you reach a point where a number equals a number that is true, so if 2 equals 2, that means there are infinitely many solutions, infinite solutions. If you say 0 equals 2, that is false, meaning there would be no solution. So that's something to keep in mind as we go into this next example. So let's take a look at these. Sometimes it's not clear what's going to be the easiest to cancel out. Okay, and this is where labeling your equations and staying organized is going to be really important. So I'm still going to label these equations A and B. And I notice that 9, say I want to cancel my y's, I know that 9 is a multiple of 3. So I can multiply this top equation times 3. And then I'm going to get some things that will cancel out. Okay, so what I'm going to end up doing, I'm going to multiply my equation A. Actually, let me erase that and write it over just a little bit. equation A. I'm going to multiply that times 3. 3 times A. And then I'm going to subtract my bottom equation from that. Okay, so multiply this times 3. I would get 15x plus 15y equals 52. In order to get those y's to cancel out, I'm going to have to subtract my b equation. So to be really careful here, I'm going to write this out. So I'm going to write out 3a. 3a is going to give me 15x, distribute this 3 plus 9y equals, distribute 3 times 52. Don't forget you have to multiply this times 3 as well, equals 156. And then my minus b, negative 1 times b is going to give me negative 15x times negative, excuse me, not times, minus 9y equals negative 54. And then now I can add these together. Okay, so 15x minus 15x gives me 0x. 9y minus 9y gives me 0. So both of my variables canceled out here. 156 minus 54 equals 102. That is false, meaning that this system has no solution. So these lines would be parallel if we graphed them. Pause the video, look at this example. This is in the bottom left corner of your notes. Hopefully you've had a chance to practice and you should have gotten 2-4. If you're stuck on that, ask me about it in class. I'm not going to go through it in the video. And then this final example, this is another one where we're going to have to use multiplication. So pause the video, give it a try. All right, hopefully you've given this a try. We're going to label our equations again, A and B. Okay, and then I see that 6 is a multiple of 2. I also see that 9 is a multiple of 3. And so something's gonna happen here. We're gonna multiply, let's say we'll multiply the first one times 3. So I want to take maybe 3 times A again. And then I want to also take negative 1 and multiply times B again. 3 times A is going to give me 6x plus 9y equals 15. And then negative 1 times B is going to give me negative 6x minus 9y equals negative 15. And then when I add these together, 6x minus 6x, 9y minus 9y, 15 minus 15, I'm going to end up with 0 equals 0. Everything cancels. This is true, which means that there are infinitely many solutions. So these would be the same line if we graph them in the coordinate plane. Okay, that's all I have. Take a look at your practice and let me know what questions you have.